My first job is to show you how simple it is to use Visual Studio to create a web application in Azure. So this is Visual Studio. I say I want a new ASP.NET web application. ASP.NET web application. I'm going to call this what's the date today? It's the 18th of January 2019 demo. So the total name of this when it's deployed will be 18jan29 demo.azurewebsites.net. You can actually give it a custom address if you want to, but I'm not going to bother with that just to make things quick. I'm going to go for the simplest template, web forms template. And it's now creating the project. And it seems to have done that. Let me just check that the recording is working. Yep, looks like it is. Okay, so let's make some really simple changes. I'm not going to run this application locally because I'm going to deploy it to Azure in a few moments. But if I just say to you, this is the default ASPX page, and if we have a look at its design, what I'm going to do is in fact, if I use Control A, I should be able to select everything on that page and just delete it. And then I'm going to get a label from the toolbox, drop it in there, and that's called label 1. There it is, look, label 1. So if I now go into the code behind page and look for the page load event, so every time this page loads when we fire up the website, I'm going to execute this piece of code. So I'm going to say that label 1 dot text, go back, dot text is equal to environment dot machine name. Okay, so all it's going to do is going to take the name of the machine and just stick it onto that web page. The name of the machine which is executing the web server, that's running the web server that's serving up the web page. Okay, so now I'm going to just deploy that. I can deploy it using web deploy straight from within Visual Studio. Look, it understands, because I've got the SDK installed, it understands that there's a Microsoft Azure app service that I can publish this to. I could also, if I wanted to, publish it to Microsoft Azure virtual machines. They would have to have the web deploy components installed onto them for that to work, but I can do that. So let's go back, let's say Microsoft Azure web app service, hit publish. It's going to give the application the name 18jan 2019 demo, and then all this GUID stuff on the back end here, and then it'll be .azurewebsites.net. I'm going to remove all this stuff. I thought I was going to remove it. Yep. Very slow keyboard reaction there. I don't know why. I'm going to remove all of that just to keep the URL simple. This is the subscription I'm going to use. It's my Azure subscription. I'm going to create a thing called a resource group to put this stuff in, and I'm going to call it RG for resource group 18 Jan 2019 demo. Get rid of that E. The keyboard is very slow at responding here for some reason. And then a thing called an app service plan, which is a location in the world where I'd like to run this. There are 54 locations in the world where we could run this, and the size of the resource. So I'm going to create a new one of these. I'll call it, leave it with its default name. We'll put it in North Europe, which is in Dublin. There's a huge region in Dublin with 5 or 6 data center buildings hosting tens of thousands, hundreds of thousands, I believe, physical servers. We're going to run this on a web server which has got 1 core, 1.75 gigs of RAM. There's different sizes I can specify here, but I'll go for the S1. Click OK and click Create. And now we just wait for this to deploy. So you can still it started to build, doing all the compilation and everything. It's sending the package to this URL, which is the publishing endpoint. It's the endpoint to which we send a web deploy package to publish the code to Azure, and then it should fire up a web browser, and we should be running. Takes a little tiny bit longer than normal because this is the first time we are running this, so it's having to provision everything for the first time. Okay, so what you can see here is that application, and remember I've removed everything from the page, well, almost everything from the page. That is the name of the machine, which is the machine in Azure which is running this web server. RD actually stands for Red Dog, which was the original name of Azure when it was a beta project. RD 818788789B5. Just remember those last three numbers there, 9B5. That's pretty much unique. If I go back to the Azure portal and I find if I refresh this and find the resource group that I created, do you remember it was called RG18Jan29? There it is, that one there, RG18Jan29 demo, 2019 demo. Let's have a little look at this resource group and show you what's in it. It's got a plan and it's got the actual app service itself. So the plan is the size of the machine and where it's located. That's in North Europe, and the application itself is the code that I'm running. Okay, so let's have a look at the configuration of the web server itself, which is running this. And couple of things. I've got a URL there. I've got a URL just there. So if I click that and go to it, it'll take me to exactly the same web page we just looked at. And it should be a little bit quicker this time because it's not provisioning for the first time. So if I copy that, go to a new tab, paste it in. Oh, something, I did that wrong. Let's go back here. Let's copy that, make sure that's copied. Come back here, get rid of this, paste in the URL. That's a bit more like it. Oh, why do these messages keep coming up? And there is the machine. That's that 9B5 machine. Okay, let's go back here. Let's come down and find the scaling options. So there's a scale out option. Click that. And it shows me that I've got one instance, one server. I can actually push this up to 10 servers if I wanted to. Or I could, that will just give me 10 servers to operate from. Let's try that. Let's save that away. So now it's very busily recruiting 9 more servers into the configuration. So now there's one other thing I want to do, and that is go to the application settings and get the load balancer, which is going to load balance across these servers. I'm going to switch off its stickiness. So that's called ARR affinity. If I switch that off, ARR affinity stands for Application Request Routing Affinity. And it says, if I connected your client to this server, then the next time you send a request, I will connect you to the same server. And then if you send another request, I'll connect you to the same server. In order to prove, I've only got one client here, so in order to prove load balancing, I'm going to have to switch that off so that it'll randomly put the data across multiple different servers. So let's save that. Now let's go back to my home page. Remember that number there, 9B5, that's the machine that's processing it. And let's do a hard reset. Control F5, I think that is. And that hasn't done it, so I'll just put a load of requests in there. If I just keep hitting the refresh button, it'll realize that I'm trying to... whenever you do this, it doesn't work, does it? Whenever you... 9B5. Okay, so that's got one. You can see there, look, 18E. Should we try again? Let's try a few. 18E. Uh, 66B, etc. So it's distributing the load across a bunch of different servers. Okay, so that's just the thing that I wanted to show you, how simple it is to get a load balanced server. Oh, one of the other things I want to show you in here is the auto scale settings. Then we go back to the app service plan, and I can enable auto scale here, so I can give that a name, and it says scale based on a metric, and scale to a specific account. So scale out and scale your instance based on a metric. For example, add a rule that increases instance count by 1 when the CPU percentage is above 70%. So now let's have a look. Let's add a rule. So instance limits minimum 1, maximum 2. Let's set the maximum, because I've got 10 servers in this configuration. Let's set the maximum to 10. Let's have a default. Why don't we have a default of 2? And then let's add a rule. Add a rule. This UI has changed since the last time I did it, so I'm going to have to sort of make this up as I go along a little bit. So the source is 18 Jan 29 demo plan. The criteria is, let's take the average time aggregation until we get to a CPU percentage. Time grain statistics, we'll go for average on that, of greater than, let's say, 80%, or let's say 81%. And when it's done that for more than 5 minutes, then the action will be increase the count by 1. And then the cooldown, so when we scale back again, is 5 minutes. So let me draw it as a diagram so you understand what that rule is, because I have no way of testing it because I can't get that much load onto the system just from one client. But we've got up to 10 servers. So let's imagine we've got one server at the moment, got a user with a laptop, and they're sending requests into Azure App Service, which is this interface that sits along here, and the load balancer routes us to one of those servers. And what we're saying is, when we get to a total of 81% utilization on that server, then bring in a new server. So now we'll have 2 servers. And of course, what that then means is that the average utilization is going to drop between the 2 servers. So now we've got not so much utilization. Let's get the red again, red, brush. So we've got 40% utilization on each of those servers. But what might happen over a period of time is that it might start to creep up in here. More users log onto the system, it creeps up a bit more, and it hits our threshold, 81%. And then what we will do is we will provision another server. And of course, that means that the average utilization is going to drop across all 3 of those servers. So let's say that drops down to there, that drops down to there, and let's imagine that this one is now operating. Get the brush again. This one is operating here. And then what we say is leave it like that, the cool off period. Let's go back. Where's my pointer gone? I can't see the pointer. Let's go back here. Add a rule, the operation, increase the count by 1, and the cooldown is 5 minutes. So once we have been, once that peak has passed, we might be down to something like, very low levels of utilization then, right down to, let's just say, something like 5%. Hopefully you're getting the idea of what I'm doing here. This is representing just 5% utilization down here. And when we've been at that very low level of utilization for 5 minutes, that's when we will remove one of the VMs. So we'll remove that VM out of the configuration. And then, of course, the average utilization is now going to go up. So let's draw that in. So it's going to go up very slightly up to here. And then we might wait another 5 minutes, and that's going to then drop off, and so on. So you can see this we're going to automatically scale based on CPU utilization. Okay. Now, the next thing is for me to describe the way that all of this works. So let's have a go at that. Let me get rid of this picture. So what we have in Azure is, let's imagine, let's get the brushes again, get the black paint. Let's imagine this is a user using some kind of a computing device which is generating HTTP requests, which goes to the internet. Here's the internet, and ends up at a public IP address, a public endpoint, which is connected to the Azure infrastructure. So in here we've got Azure done in the Azure color. So all of this stuff is Azure in here. So what we're going to do? Well, we're going to go to this sort of, it's not its name, but I'm going to call this a facade. Need to have the little squiggle. The squiggle go on the top? I can't remember for facade. Well, that says facade anyway. And that consists of servers at the front end here that will do the load balancing. I think there's 3 by default. But actually in Azure there's tens of thousands, or well, maybe thousands of them anyway. And then, you know, I had a single VM at first, didn't I? So I got a single VM, and that's running Windows, and in my case IIS, and my application, which was sat on the top of it. Now that application came from a shared storage area. Shared storage. And it exposes a publishing endpoint. And that allows me to do something like over here, over on the left hand side. Let's do it in orange. Let's fire up a copy of Visual Studio. Let's get a web deploy package. There it is. Look, there's my web deploy package. And let's put it onto that endpoint. So what will happen is I will hit publish in Visual Studio, and that will cause Visual Studio to send this as a packet across. It will go through the front ends, it will go to the publishing endpoint, and it will end up on this bit of shared infrastructure here. And then the fact that I've got an application, that is how my application gets there. So when a scale-up operation occurs, let's imagine that we hit that 80% or 81% threshold again. And then what happens is one of the spare VMs in Azure, let's draw a brush again, go back to that color. So we'll bring a new VM into the configuration. That's going to have Windows Server, IIS, and how's it going to get the application? It's going to connect to that shared storage where I published the stuff to before. And then if the utilization goes up again, we'll have another server brought into the configuration. It's going to be running Windows, W, IIS, and it's going to be connected to that shared storage to get my application. And these this facade at the front here is going to do the load balancing across the different servers. And you saw, if I switched off application request routing, you saw that that happened automatically. That it took a while for me to start overloading the system, but when I hit Control F5 lots and lots of times really quickly, it then started to load balance across all the different systems because it had been already stickily connected to one and thought, well, might as well carry on. But of course, when you send so many requests, then it starts to load balance across all of the instances. So let me just make sure I make that clear. If I had a different client, let's imagine I had a different machine here, and then another machine over here, and another machine here. Let's imagine this one is in the UK, this one is in France, and this one is in China. If this generates an HTTP request, then what would happen is that request would go across the internet, hit this thing here, and it might say, I'm going to get it serviced by this guy up here. This guy is going to actually run the code that's going to service that request. The load balancer will remember where the packet came from, what the protocol was, what the port was, and where it went to. So the next time this guy, let's do brushes again. The next time this guy generates an HTTP request, and it goes up here, across here, it hits this front end, and this front end is doing the load balancing, and it says, oh, the last time I got something from that IP address using that protocol on that port, I sent it to this server, so I'll send it here again. So that's how the load balancing is going to work. Now, if we get a request from a different client, let's go black and brushes again. So let's imagine we got a client in France. Then what's going to happen this time, possibly, more than likely, is the request will go to the internet, hit this public IP address, come to the load balancer, and the load balancer might say, oh, I'm going to route that to this server. And then if somebody in France does another packet, let's get the brushes back. There's another one there. Then what's going to happen? This packet is going to come across, hit the Azure load balancer. It's going to say, last time I had something from that IP address, that port, that protocol, I routed it to here, so I'm going to route it to here again. Now, one of the things you might have remembered that I did was I switched off ARR affinity. So there's this property on this front end here called ARR affinity. Can't remember if there's two F's in affinity, isn't there? ARR affinity. So that affinity means, you know, the likelihood of some things coming together. So what might happen in this case is if we go back to our UK-based person here who generates another HTTP request, because we've got ARR affinity switched off, the HTTP request goes across the internet, hits the public IP address, handed on to the front end. The front end is the load balancer. ARR affinity is set off. So whereas it would normally have sent it here because of it says, last time I got a packet from that IP address, that port, and that protocol, I sent it here. But that's affinity, and I've switched affinity off. So in this case, it might send it here. And then if I had another packet, let's get the brushes again, put another packet here, and I posted that in, posted in here, it might say, well, I've got no affinity, so it doesn't matter which one I send it to, and it might send it to this one. And that's how we were able to show you different machine names processing the request as we did that. Okay, so that's the real sort of core basics of how app service works, worth understanding about the publishing endpoint, because it means if I make a change, the web deploy protocol will allow me to just publish the change from Visual Studio to the environment. So let's give that a go. Let's go to Visual Studio. Let's take that default.aspx, that one there. Let's get that default.aspx page. Hit design, and let's just do something like, whoops. Let's try again. Default.aspx. Hit the design. It's going to let me put some content in here somewhere, hasn't it? Default.aspx. I think because there we go. I've got no entry signs everywhere. I must be able to do it in the HTML. Let's have a go. Design split source. Oh, isn't this annoying? Let's call this home page. Let's call this new home page. Save that away and then republish. So I've made a change. I mean, this would probably actually not be just a small change to the title of the page. It would probably be hundreds of lines of code, but let's just imagine that we've done that. Now when I publish, rather than sending everything, it's just going to send the one file that's changed. Oh, here we go, publish. So it's built it. Look at that. Look, publish started. Should be pretty quickly. Starting the web deploy, and it's that endpoint there. That endpoint is this publishing endpoint, this one here. Let me circle it in red. This publishing endpoint here. Oh. Brushes. So let me get rid of that. This publishing endpoint here, and the shared location. That's where it's gone to. Let's go back to Visual Studio. Probably done it by now. I know it's adding ACLs at the moment, or is it? Let's come down here and see if it's finished. Publishing succeeded. So now when we go back to that page and refresh it, so it says, look up here, it actually says new home page. Do you remember I retitled it to new home page? So if I take this one and refresh, it should come up there. Rather than saying home page, it should say new home page. There we go, new home page, and serviced by that original virtual machine. Okay. Now the next thing to think about is sometimes you might want to have a completely isolated environment, because let's go back to our picture here. You know, this, although the VMs here, let me do this in green. Let me just say that VM, and that VM is dedicated entirely to you. These servers that are in your front end, which do the load balancing and lots of other jobs as well, they're entirely dedicated to you. But if I was to redraw this picture, let me just do a file, new, don't save, brushes, black. Here we've got Azure. We've got all those VMs that make up, you know, they're running IIS. Actually, you can get them to execute Docker, or let's imagine that's a load of them, and let's copy all of those. So this is Azure with all of its VMs, which are running Windows and IIS, or if you've chosen a Linux application, it would be Linux and Apache, or if you've chosen Docker, it would be running the Docker environment. So this is all this stuff. And you know what happens is you get a little partition of that. So let's just imagine that you build your app service. Then what you will get for your app service, let's imagine this is your app services endpoint. Let's get back to the brushes again. This is your app services endpoint, and it's 18 Jan 2019 demo dot Azure web sites .net. What happens is it says, right, I'm going to get those machines there, let's just say, as your front end. And I'm going to get these machines over here as your back end, where your actual work is going to be done. So there's no sort of boundaries around it, you know. So what you can do is you can create a completely isolated environment where what would happen would be the machines that you were going to use would be taken and they'd be removed, and these machines would not be part of that large infrastructure. There would be almost like a fence. Let's draw the brushes again. There'd be a fence around the outside of this which completely protects it and isolates it from absolutely everything else. I think the thing that people worry about it's probably an invalid worry, but it's a worry that they do have, is, let's imagine this in blue. What if somebody was to come in, get into your front end, get into this service, into this server here, and somehow find a way to hop into some of this infrastructure here, or somehow find a way to hop into this infrastructure down here? Now, we believe that we've architected it in a way that that won't happen, but you might feel nervous about that and decide that you want an absolutely isolated environment. Also, we've got the noisy neighbor problem. Because we're dynamically moving these servers into and out of your configuration, depending on things like scaling rules, we might be moving a server in to your configuration which has just been used by somebody else and is in its cooldown period where it's starting to free up resources, meaning that you might get a slower server. So there's another reason why you might want to have this completely and utterly isolated environment, and we call this an app service environment, an ASE. You'll quite often hear people calling it an ACE. I think it should be an ACE, but an ACE is what you'll hear them calling it. And that will have your servers which form your front end, your servers which form your back end, and it will have all the infrastructure that it needs to work in the way that I just explained. So, it'll have a publishing endpoint, it'll have a place that you go to. One of the most interesting things about this, though, is that one of the elements that you could have inside your Azure in your Azure environment is a virtual network. And the ASE can connect your instances through to an internal load balancer, which is in turn connected to your virtual network, your VNet. So you might want to have a app service environment. Because one of the things you can do with a VNet is you can put a gateway on it, and that gateway can take you back over a VPN to your corporate network. Let's imagine that's your CorpNet there. Or this might not be a VPN, this might be an express route connection, which is a dedicated fiber connection between you and the Azure data center. So if you wanted something to be purely available internally and not even exposed to the public internet, then that might be another reason why you would want an app service environment, an ASE or an ACE. So let's go through the process now of building an ACE so that we can understand how it works. Okay, so we're going to go into the portal. Let's drop these things here. This is the portal. We'll look at all services, and we're going to create an app service environment. This one here. This is that isolated environment I was just telling you about. Yeah, I've got some unsaved edits. I'm not really going to worry about these rules and so on. Okay, so let's create an app service environment. So we've got to give it a name. So let's call this ASE Planky. So whereas before we were using the Microsoft infrastructure, the name of the application was 18 Jan 2019 demo.azurewebsites.net. There's always going to be the name of the application .azurewebsites.net. In this case, we're going to have it's going to be called .p.azurewebsites.net. So we're going to end up with an app service environment called aseplanky.p.azurewebsites.net, and that will be the environment itself. Okay, so we're going to have a resource group. I'm going to call this one rg-ase Planky. And then I need a virtual network, because remember, there's different types of ASE. And we're going to build an internal one. An external one as well uses a virtual network, but we're going to need a virtual network for that. So this is a network. It's a bit like a VLAN running in Azure. So it's created one for me, and the type is external, but I want to change that to be an internal one because we're just going to use this purely internally. And we're going to give this a domain name that we're going to use. So let's call it aseplankynet.com. Why not? It's as good a name as any. Let's have a look at this virtual network. So it's put it into a location which I know is not going to be a very good location for it because the UK South is so strapped for resources that I am going to put it into central US, I think. Actually, I can put it in West Europe. EJ, I think they're at the bottom. West Europe. Say OK to that. I'm sure I'll get the chance to do the subnetting in a minute. No, I don't get the chance to do that. Say OK. And say create. So this is now going to take about 2 hours to generate the environment. So I'm going to use the magic of video editing to make this process a lot quicker. Okay, so let's look in here, the notifications area, and it says the deployment has succeeded. So that should mean if I now refresh this, we should see an ASE and an ACE, an app service environment here. Now let's have a look at it itself. In fact, let's go and have a look at the resource group for that ASE. That's ASE Planky, that one there. When we look at the resources that have been created, it created the virtual network, it created the root table to go with that virtual network, it created the network security group to go with that, to go into that subnet, into that virtual network, and it created the app service environment. So the process of creating the app service environment created a few other things, and we kind of said what we would name the VNet, didn't we? I think it came up with that name by default, which is ASE Planky, the name of the ASE, -VNet. Let's have a look at that virtual network and have a look at its subnets. So it's got a single subnet called the ASE Planky subnet 192.168.250.0/24. So that means in that subnet we have probably at address, well, it'll show us the address in a minute, but probably at address 192.168.250.4, I'm suspecting, we will have our app service environment's internal load balancer. Now that will all become clear in a minute. In order for us to talk to this, we'll have the app service environment has to have its own dedicated subnet, and there can be nothing else on that subnet. So we'll come back to that. Let's go back to the app service environment. Resource groups. There was probably a quicker route to it than that, but let's have a look. ASE. Oh look, I called it ASE Plan JK while I put a J in there by accident. That's because it's right next to the K on the keyboard. So let's go back to the ASE. And let's have a look at this list here of IP addresses. So it created the virtual network, and there are some IP addresses that it automatically creates. So it says the domain and subdomain name is going to be aseplankynet.com. That's the name that I gave it when I created it. The internal load balancer's IP address is 192.168.250.11. Remember that. I said it might be .4, didn't I? This must be some reason that it's .11. I mean, it can't be .0 because that's reserved for broadcast addresses. It can't be .1 because I think that is normally the default router. It can't be .2 or 3 because that is just in case sometime in the future we allow the gateway subnet to be on a normal subnet. That will take up those two addresses. So it's normally .4, which is the first available address. In this case, it's not that, it's .11, so there must be some reason for it. They didn't just randomly pick that. There must be some restrictions on the other IP addresses, which I don't know what they are yet. And then it's got a management IP address, 23.97.130.123, and the same IP address for outbound traffic. So this is, for to manage the environment, we've got a public IP address, and to what is its IP address for outbound traffic? It's that one there. Okay, so I guess the first thing we would want to do is to let's create a web app. Let me draw the diagram first of all. So that's what do you remember that's what we were looking at earlier? And we were concentrating on, let me highlight it in red, really this bit here. That was the bit we were concentrating on. So let's draw the new environment. We don't save that. So what we've now got is, let's do it in black with that brush. We've got a virtual network. And in that network, we've got a subnet, and that's at 192.168.250.0/24. /24 means that our subnet is masked off by the first 24 bits. So we start sliding a network mask in that way, and it comes along like this, and it slides up the first 8 bits, the next 8 bits, and the next 8 bits. So that so a typical way of doing subnetting is to say that 192.168.250 is the first subnet, and then this range here, this can be any range of addresses from 0 through to 255. But you can't use 0 because that's broadcast. You can't use 1 because that is the default router. You can't use 2 or 3 because those are reserved for the future for gateways. Usually the first host is 4. I'm not doing a very good job of explaining this, am I? Yeah, okay, so that's that. And you can't use 255 because that's also a broadcast address. So we've got a total of 256 addresses available, but there's 1, 2, 3, 4, 5 that we can't use. So 256 minus 5 equals 251. And that's the total range of addresses it says that we've got in the portal, isn't it? If we go back to the portal and have a look. I need to go to the VNet. Let's have a look, virtual networks. That one there, ASE Blanky VNet. Go to the subnets. And it says here, look, available addresses, you can see that there, is 251. 192.168.250.0/24. Let's go back to this picture here. So I'm gonna have another go at explaining this because I don't think I did a very good job there. Let's get rid of that. And get rid of that as well. So we have a virtual, let's get the brushes back. We have a virtual network, and that's divided into, the IP address goes A.B.C.D, doesn't it? And there's 8 bits allocated for that. 8 bits, let's just do a quick bit of binary. 8 bits gives you everything from 0, 0, 0, 0, 0, 0, 0, 0, 0, and then the next would be 0, 0, 0, 0, 0, 0, 0, 1, and then it would be 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, etc. all the way up to 1, 2, 3, 4, 5, 6, 7, 8. Now the decimal value of that is 0, and the decimal value of that is 255. So all the range of addresses all the way through gives us a total, not of 255 addresses, because we start counting at 0, a total of 256 addresses. So we've got 256 numbers that we could have in there, anything between 0 and 255. Another 8 bits there, anything between 0 and 255. Another 8 bits there, anything between 0 and 255. And another 8 bits there, anything between 0 and 255. And what we've actually got for our subnet is we're taking the first 3 bytes and we're allocating those to, what they do is they point to the subnet. That's right, sort of, yeah, it's close enough. They point to the subnet, and the address they're pointing to is 192.168.250.0. So this portion here is the subnet address, and this portion here gives us up to 256 possible host addresses within that subnet. But remember, we can't use 0 because that's for broadcast. We can't use 1 because that's for the default router. We can't use 2 and 3 because that's been reserved for future use when we might want to put a gateway on here and it will have an active and a passive member, or even an active-active. And we can't use 255 because that's also reserved for broadcast. So that's 1, 2, 3, 4, 5 addresses. So out of the 256 addresses, we've got to subtract 5, and that leaves us with 251 possible host addresses. Okay. Within that range of addresses, we know that 192.168.250.11 has been allocated to the internal load balancer, which is connected to the app service environment. Okay, I'm hoping that explains the /24. The /24 is masking off these top 3 bits to say all of these bits here, they determine the subnet, and these bits here, they determine the host within the host address within that subnet. And just to sort of put a bit more clarity on it, I suppose, the first subnet will be 192.168.250. Highlight it in red. So this is going to be the first subnet. And let's carry on with the numbers. So the next one will be 192.168.251. And the next one will be 192.168.252. The next one will be 192.168.253, and so on. So we can have lots of different subnets, and we can have up to 251 hosts within each of those subnets, but we're really only going to have one subnet. We're only going to have one subnet for the app service environment, and that's this one here, 192.168.250.0/24. /24. 24 masks off that 24 bits at the top there. Right, next. What do I need to do next? Oh yes, I remember. It was to create an Azure web app using app service, but using the one that we've created here, our own isolated app service environment. Now, if you just think about it, we've got all these different locations all over the world. Let's just do a new here. Microsoft has got, at the time that I write this, or that I record this, 54 regions in the world with 2 in preview. That's 56 altogether. That number is forever increasing. So we've got a sort of, I'm going to have to draw a map now of the world. Let's start with the UK. There you go. Let's put France and Spain, Italy, something like that, isn't it? Greece, Turkey, all the Middle East, North Africa, Africa. Arabia, come over here, India, China, Russia, Norway, Sweden, all that stuff up there. And then over here, something that roughly fits into that looks something like that. And that's the USA. And in this location, we've got data centers in the UK. We've got one in Dublin, one in Amsterdam. We got them sort of dotted all over the place. Actually, there's not that many in Africa. The ones in Africa tend to be down in the southwest. And there's a total of 54 of these different data centers. Okay, and each one of those is a completely isolated environment. So this one is isolated from this one, which is isolated from this one, which is isolated from this one. So let's have a look at using the app service environment that we have created, our own isolated app service environment that we have created, in order to create a website like I did earlier. So we go into the portal and we go to all services and we go to app services. You remember I did this earlier? I created an app service, didn't I? I created one called 18 Jan 2019 demo. It's currently running. It's a web app. It's on that app service plan. And if I click this, it'll show me where it's running. No, it doesn't. No. Okay, I'd have to click there. I'm not going to do it because it takes too long. Okay, so let's do add, and we're going to create a new app service. So let's just do a web application. Say create. So I'm going to give this a name. We know it's going to be something.azurewebsites.net, but it's not. Something's gone wrong here. Let's try that again. Close that down. Close that down. Oh yeah, that's what it is. The app service plan is the element when you create a website which determines the location and the size of the virtual machine or machines you'll be using. So what I'll do is I'll do it again. In fact, what I'll do is I'll create the app service plan. I think you can create the app service plan as part of creating the web app. So if I say I want to create a web app, and I hit this create button, it comes up with this name. Yep, but that'll change later. So let's call this ASE Planky Web App. So it appears it's going to end up being called ASE Planky Web App.azurewebsites.net because that's the default domain suffix that we use. But I'll show you how that's going to change in a minute. I'm going to use my default subscription. I'm going to use an existing resource group, and that's the one that I created earlier for all of this stuff. It was called RG ASE Planky, that one there. We'll use Windows. If I was to specify Linux, then all the VMs would be running Apache and it would be different. And if I want to publish just straightforward code into Windows, but I could use a Docker image as well if I wanted to. So here, this is the app service plan. So this is where things are going to look a bit different now. If I go to the app service plan and say I don't want to use your suggested app service plan, I want to create a brand new one. So create a brand new one. And it says enter a name for your app service plan. So let's call this one. What did we call we called it ASE Planky Web App Plan. Let's call it that. And then it says where in the world do you want to create this? And look, I just created an app service environment called ASE Planky, didn't I? Do you remember that? And we just spent a whole, like probably about 30 minutes doing it. and it was in West Europe. So if I click this, it shows me all the other places around the world where I could deploy a web app, but I'm going to choose my isolated environment where I created that ASE, that one there. And then the pricing tier, I've got to use the isolated pricing tier because this is it's an isolated environment. So to get that isolation, there's VMs that I have to use. Let's have a look at this. And we could go to, I think if we go to production. Production pricing tiers are not available for your configuration and are only available to plans that are not hosted within an app service environment. And you'll find it's the same for dev and test. Dev and test are not available for your configuration, only available for plans that are not hosted in an app service environment. So I have to use an isolated plan, and these are the, we know where it's going to be. It's going to be in West Europe because that's where my ASE is. I can have 3 gigs, 7 gigs, or 14 gigs of RAM. I'm going to go for the cheapest one of the lot and hit apply. And then I say OK. So it's now going to go through, I've got to carry on down here, and then I can hit create. So I hit create. It validates all the information that I've just given it, and then it goes through the process of deploying it. So that is now deploying that onto the app service environment, and we'll see how that gets on when it's finished. And what we can do is have a look. If we go to app services here and have a look, we should see one running. ASE Planky web app, and let's have a look at that. That is the web app that is running in my app service environment. So it's only going to have, it creates a skeleton website with one page on it that says something like, "Well, whoop-de-doo, you've created a website." Let's just have a look at it. In fact, we're not going to be able to see that because the problem is it's not connected to the public internet. So when I use the name of it, I'm not going to be able to find it. Oh yes, I'm sorry. The other thing I was going to tell you was, do you remember it suggested that the name of the web app was going to be .azurewebsites.net, didn't it? But look, if I look at the URL here, it says ASE Planky web app. That's what we called it, but it's Oops, let me just go back. Hit the wrong button there. ASE Planky web app .aseplankynet.com, because that was the domain suffix that we gave to our app service environment, and that's where it's going to be hosted. But this name is only shown on that VNet that we were talking about earlier. So what have we got to do now? The next thing we really need to do is build a VM on the same VNet. If it's going to go on the same VNet and the app service environment needs to be in its own subnet, I need to add a subnet to that existing VNet. So let's do that next. In fact, let me just quickly draw that to make sure you understand what I'm talking about here. Let's do File, New, don't save. And go for the black color and that brush. So we've got a VNet here. I can't remember what it was called. It was something like ASE Planky -VNet. It's got a subnet in it. We know that subnet is 192.168.250.0/24, meaning that those bits there define what the subnet is. And we know that on here we have got an internal load balancer, which load balances to all the bits that are part of my app service environment. And I've specified that I've only got one VM. So down in here somewhere we've got a VM which is running IIS, and that has got the default website running on it. The default Azure website. It just says something like, "Congratulations, you've created an Azure website." But the point is, this VM, which is part of this app service environment, is connected to this VNet. And this VNet has no connection to the outside world. So what I'm now going to do is create another subnet over here. And why don't I make that one 192.168.251.0, because we've got a 250 over here, so 251. And I will put a VM on here. I'll put a VM, one that's got Visual Studio 2017 Community Edition. And I should be able to fire up Visual Studio on this machine and deploy an application through this VNet, in through this, and onto that VM. And then I should be able to fire up Internet Explorer, and is that how it looks? Something like that, isn't it? Internet Explorer, and actually view what's on that site. So first job then is the VNet. Let's go and have a look at that VNet. So let's go to Virtual Networks. That is Virtual Networks. What's the one? Lost it. ASE Planky VNet. Okay, subnets. We know there's only one there because we've already looked at it. So let's add a new subnet. Look at this. Look, you can add a normal subnet or you can add a gateway subnet. That is a gateway for. It's called the Azure Gateway. And it is used to create a virtual private network between this subnet and something that you've got somewhere else, like on premises, for example. Right, so I'm just going to create a normal subnet. Should we give it the name workstation? Because this is where all our workstations are going to be. So it's even worked out that it wants it to be 192.168.251.0 because it knows that's the next available address. So it's just automatically done that for me, no need to type it in. We won't worry about network security groups or route tables. By default, when you create a subnet, let me go here. By default, when you create a VNet, any subnet in that VNet, the routing, because actually, let me draw this as well. Actually, these two subnets both connect to a router. However many subnets you put into a VNet, by default there will be entries made into that routing table so that they can all route to each other. So every VNet can see, every host on every VNet can see every other host on every other VNet, unless you put some kind of protections in place, which we won't do for this because we're trying to just show that it will actually work. Okay, let's go back. So route table, we won't worry about the route table. There's a default route table which is created by Azure and routes everything to everything. Service endpoints, we're not interested in that. It's completely separate, and subnet delegations, completely separate discussion. We're not going to get involved in that. So we'll just add that subnet. Say OK, and that's called our workstation subnet. And we just have to, it's pretty quick. Again, only 251 addresses available because it's the same rules. It's just called the workstation subnet. Then the next thing we need to do is put a VM with Visual Studio on it onto that workstation subnet. So the next thing then is virtual machine. Let's do add. Right, so the resource group I'm going to use is the one that I've already created for everything, RG ASE Planky. The name of this machine can be dev workstation ASE Planky. That makes sense, doesn't it? This is going to be in West Europe because that's where everything else is. I want it to be, it's got to go into West Europe because that's where the VNet is. Is that where the VNet is? It is, isn't it? Let's just check. Make sure the VNet is in West Europe. Azure portal. Virtual networks. I'm sure I did put it in there because the ASE is in. The ASE I'm sure is in West Europe. Amsterdam. ASE Planky VNet. Location West Europe, yes. So I can close that down because I just confuses things. So the region is going to be West Europe. At the bottom of this, West Europe. We're not going to worry about redundancy. The image, we're not going to use Ubuntu or any of the default images because we want one with Visual Studio on it because we're going to actually deploy an application to the environment. So let's do a search for Visual Studio. Visual Studio Enterprise 2017. No, Visual Studio Community 2017. That's the one I want, the free version. Okay, standard D2 V3, 2 CPUs and 8 gigs of RAM. Let's boost that up a little bit to a typical developer workstation, which might have 8 cores and 32 gigs, something like that. Do you think? Let's have a look. The 8 cores and 56 gigs of RAM. Well, I'm only going to have it for a little while, so maybe. Oh no, look at that! Look, 2 cores and 16 gigs of RAM. What is that? Let's have a little look at something with 8 and 14. 4 cores and 32 gigs of RAM. I think that is a very typical developer workstation. Let's select that one, because I'm going to delete it once I've done it, and so it's only going to cost me a few pennies, or cost my boss a few pennies. So I need a username and a password. Okay, do I want to allow ports to be open? Let's say we want HTTP and RDP to be open, so that we can RDP into this machine. Do I already have a Windows license? I work for Microsoft. Yep, got hundreds of them. License type, Windows Server. Confirmation, yes, I confirm it. So I'm kind of like, you could always not tick that box and get things for cheaper. But if a software audit was done on you, you'd be in a tricky situation. Okay, disks. I'm going to go for the cheapest one, which is a standard hard drive. I'm not going to have any data disks. Just stick with the operating system disk. Networking. It says, which virtual network do you want to go on to? We'll go on to ASE Planky. What subnet? We're going to go into the workstation subnet. You see that? It's pretty clever. It knows not to use the other subnet. This is the public IP address that will be used for me to RDP into this machine. Let's stick with a basic NIC security group for the NIC. We'll allow those ports, which we've already done. We're not doing accelerated networking because don't think that tier of machine's got it anyway. And you wouldn't really want, you can't load balance Visual Studio, so there's no point in doing that. Next, management. So these are all defaults. We'll have the boot diagnostics on, OS guest diagnostics off. Let it create a storage account for us for the diagnostics. We will dispense with managed identity, and we will enable auto shutdown so that at least if I make a mistake and this stays running for a little while, it will switch off at 7 o'clock this evening. Notification before shutdown not needed because I'm the only user of this machine. So any configuration that I want to do? No, I don't want to use any extensions or anything like that. Do I want to do any tagging? No. Okay, so review and create. Does this all look good? Yeah, I'm sure it does. So let's click the create button. And now we've got to wait for a little while it creates the virtual machine. So I think that said it was finished then. Let's go and have a look. So there is the VM. Shall we? And it has started. So in order to connect to a web page, the internal load balancer for the app service environment, it won't work unless, even though we're not going to use HTTPS, for it to work, we have to load a certificate for it. I have, let's go to the ILB first of all. Resource groups is the easiest way to get there because we know we'll be able to connect to the right one then. RG ASE Planky. let's look for the internal load. Where's no internal load balancer? That's a bit odd, isn't it? Let me think about that. I think we go into find the ILB here. Look, ILB certificate. Oh, there's a scale operation pro still doing something. Okay. Let's try that again. ILB certificate. Ah, that's a bit better. Right, okay. So I don't have a certificate at the moment. I need to create one. And you know what I would normally do is go to the PKI or the certificate authority or the issuing authority or whatever. However I do certificates in my organization, I'd probably use that. What I'm going to use is a self-signed certificate, which I'm just going to use PowerShell to create, and I've actually taken the liberty of putting the code here so you can copy it. So there's a variable called certificate, and it uses new self-signed certificate. The store location for the certificate is my, which is the same, it's local machine my. The DNS name, this is the wrong name because this is the example code that I got, so I need to change that to what was this sub thing name? It was ASE Planky Net. I can't remember what it was now. Let me have a little think about that. I think I just go to the overview page, not of the app service environment, and it's aseplankynet.com. Yes, I must configure a ILB certificate. So let's go back here. So it's star.aseplanky.com.net. That is what it's called, isn't it? aseplankynet.com. Let's change that. aseplanky. Let's get this right. aseplankynet.com. And then we have to do the same thing again. I'll explain this in a second. Get rid of this Contoso stuff. All the examples are Contoso, aren't they? Right, so we will now have a certificate which has got two DNS names. The subject name is all in this this commandlet, self-signed certificate, gives you a parameter which is minus DNS name. The first name in there, which I've got as a string, it says star.aseplankynet.com. That is the subject name, the certificate subject name. And then the next one, so if you do a comma, then the next one, you have a quote, star.scm.aseplankynet.com. Was it .com? Yes, it was .com, wasn't it? Let's just go back here and check. Yes, it was .com. Go back here. This SCM part here is for a system which is known as Kudu, and that gives you access to the management of your environment. It's something, actually, you need the SCM, the star.scm.aseplankynet.com, the SCM part you need for using web deploy to deploy to the web deploy endpoint. So we need those two names. Okay, so you will put that bit there will be your domain name, and you'll have your domain name there as well, aseplankynet.com, with an SCM in front of it. Okay, the thumbprint is just a one-way hash, and it's of the certificate in the my, which is the local store, and we want the thumbprint from it, The password is where we use a password. I'm going to change this password. I'll just change this password. So that's going to be the password. That's going to be plain text string. And then the file name that we're going to export this to is going to be called exported-cert.pfx. Now, if I run this as an administrator, it's probably going to end up in Windows or Windows System 32. I've done it quite a few times in the past, and that's where it's ended up. So when we use the when we export that, then we the file name equals that, and then we've got export certificate, and the certificate name is what we put into the thumbprint, and the file path is what was in the file name, which is this one here. So we're going to have a certificate called exported cert, and the password is whatever we put here. So let's fire this up as administrator. Oh, that's annoying, isn't it? Let's do ISE. What does PowerShell ISE run as administrator? Right. So let's get that. Now let me just highlight something here. If I get that command, missed off. If I get that command, put it in here. Put it in here. It would be easy, now that I've told you that you need to have a subject name, which is the DNS name of your site, and alternate subject alternate name, to think that you go to subject, you think you put it in here as an entry, and that there would be a subject alternate name, and there isn't such a parameter. It's just DNS name. So if we come up here somewhere, it's that one there. So if you're using this way of doing PowerShell, you put the DNS name in there, and then you put a comma, and you put star.scm. whatever your DNS name is. Right. So let's just get rid of that. Let's get our code. All of this stuff here. And you're obviously going to have to type it all in manually. Sorry about that. Paste that here. All looks pretty good to me. Okay, and shall we highlight it all and execute it? Alright, so let's put it in Windows System 32. If I do dirxp exported cert.pfx, it's that one there. What's that say? 18th of the 1st at 1518. That is now. So we've got a certificate there. So what I'll do is get that path. Oops, get that path there. It's missing the 2 off the end. Copy it. Let's get rid of this PowerShell environment. Let's just minimize that. And let's go to our ILB certificate. And let's upload the certificate. So update the certificate. So select the file. That's where I am. Alright. Can't open System 32. This PC. I'm logged in as a. Oh, look at that! Look. Oh, that should still be okay. OS Windows System 32. Didn't seem to have any problem there, did it? And now we're looking for exported exp exported cert.pfx. So that's what we're picking. Open that. The password was that string that was in here. Change this password. Of course, in a production environment, you'd be a lot more circumspect about what I'm doing here, but this is just a demo. Where was I? Back here. Put the password in. So that password is used to protect the private key that's in that certificate. And then click upload. That's going to upload that. It says it's done. So now if I go, should we now connect to the, let's RDP into the VM and see if we can see the website that is running in that app service environment. And that'll prove that it's working. So virtual machines. And it was called something like Dev Workstation ASE Planky. So it might take a little while configuring the desktop of this machine. Right, so RDP, public IP address, port number, download the RDP file. Let's just open it straight. I quite often save it onto the desktop and make a few edits to quite often connect to it, but I don't need to now. So if I do that, it'll ignore all the domain names and all that kind of stuff. This should connect me to the machine. So I'm going over the public internet to connect to this machine, but it's on a private VNet. So I'm just using this as the mechanism to get access to the screen, the keyboard, and the mouse. You would actually do this. Probably you would have the VNet in your app service environment connected over VPN to your corporate network, and this machine I'm connecting to now, I'm connecting over the public internet. This would be on your corporate network, and you would be logging directly into the physical machine. Of course, this is going to take a little while because it's building the Windows desktop. So let's let that build for a little while and see what happens. So stuff has happened. Let's maximize that again. Server manager's firing up. Do we want this PC to be discoverable by other PCs? Let's say no to that. Okay, so the next thing I need to do is the DNS for the virtual network has to be managed by whoever owns the virtual network. I'm not going to set up a DNS server. Although I could add that as a role, couldn't I, to this machine? What I'll do is go for the much simpler option of finding the IP address, which I believe was 192.168.250.11, wasn't it, for the internal load balancer? Shall we check that? Forget about that. Let's go back to the app service environment. Not that one. App service environments. Should only have one of them, that one there. Let's have a look at the IP addresses. And it says the internal load balancer's IP address is 192.168.250.11. That's what I said it would be. Right, so if I now go back here and go into the hosts file and make an entry into the hosts file for the DNS name. What did I call the website? Let's just fire up Notepad here and make a note of all these things. All right, and there we go. So it's 192.168.250.11. And what was the name of the machine? I can't remember what the name was, but if we go to app services down here, we should see the one that we've just built in that app service environment. ASE Planky web app, that was it. So let's have a look at its URL in the information page to make sure we get the complete path absolutely correct. We'll come up here. There it is. If I copy that and go back here, back to Notepad, put that in there. We don't want the HTTPS because this is only DNS we're dealing with here. Oh. Right, so now if I find the hosts file, which is going to be on this PC, C drive, Windows, System 32, is it etc. drivers or drivers etc.? I can never remember. The drivers, etc. There's the hosts file. So let's, I think I've got to open that as an administrator. No, actually I don't. I'm logged in as an administrator, so I can open that file with Notepad. And then down here, I will put, it's all commented out, but I will put the local address, that one there. Looks like it goes about there, doesn't it? And the DNS name, which is that one there. And then save that file. Just did a Control S. I could close it down because that's all that we need in there. And then I think it's probably, let me leave that there. It's probably a good idea to fire up a command prompt and let's just do ipconfig//DNS. So I've never connected to that DNS name from this machine, but it just absolutely clears the cache, so we're not going to get any cache type problems. Right, so now let's go to, well, I think we need to go to Server Manager and switch off local server, switch off enhanced security. Oh, it's off. Okay, yeah, that's what happens these days, isn't it? For the administrator it's off, for users it's on. Okay, let's live with that. Let's go to to Internet Explorer. So shall I draw a diagram just to show you what's about to happen? Let's go File, New, don't save. So we have got a virtual machine which has got an entry in the hosts file which says whatever the, how is that happening? I switched off my muted notifications. Whatever the DNS name goes to 192.168.250.11. That's connected to a virtual network. It's connected to its own subnet on that virtual network. We know that there is routing between subnets in the network. On the other, this is called the workstation subnet. This subnet is called something like ASE Planky, something like that. I can't remember the actual name. That has got the ASE environment in it, and it's got a single VM that I created, and it's got the ASE environment, the single VM, and the way that there's a load balancer on here, an internal load balancer, ILB, and its address is 192.168. 192.168.250.11, and that internal load balancer is I'm going to connect to that, and it's going to route me to that IIS box, which is going to deliver the default.aspx, or whatever the default page is for that, for the server. Okay, so let's do it. So I need to get into this virtual machine. Yeah. And I've just forgotten the name of the environment. Oh, I've got it in the file, haven't I? In that, I had a notepad file. There it is. So let's copy that, put it into Internet Explorer. Let's be really specific about it, shall we? Just to be sure. Let me just show you what that says in case you can't quite see everything. App. Now, I'm sure I put HTTP there just now. HTTP : / I've done it twice now, look. HTTP : / app. app.aseplanky.net. That doesn't look right to me. HTTP : / Control V. That's better. Right, hit return. And it says your app service app is up and running. Marvelous. Okay, so it's all working. The bit that might not work is the Visual Studio publishing part, but I actually can't show you that because I've run out of time. I need to leave the office right now. I've got a meeting to go to. But I'm hoping that shows you what you can do. This is a website which is running on a virtual network, which is in an isolated environment, which is in no way connected to any of the networking and the stuff that's in the Azure core. And one thing I could do additionally to this is, let me just quickly draw a diagram to explain the extra thing I could do. Rather than having that VM there, what I could do is put a WAF here. Oh, black brushes. I could put a web application firewall here, and I could say that its backend backend pool is connected to this subnet, that the target is the IP address of the internal load balancer, it's this one here, and I could have its public IP address on the internet with some name or other. Let's make it, let's put a name here like this. But let's make it not that name, let's make it WAF dot. So we could give it a name of waf.aseplankyweb.app.aseplankeynet.com, and anybody coming in would go, let's just draw a user out here on the internet. Where's the pen's gone? Brushes. So here's a user, bad person, wants to do something like a SQL injection attack. They send an HTTP request with SQL injection attack data in it. That comes across, hits the pip, through the WAF, gets routed onto this subnet, routed automatically, because routing is enabled for all subnets, to the 192.168.250.11, which is the internet load balancer, which then eventually routes it onto IIS. But on its journey, of course, it will have got to this point here, and let's draw a little bit of extra stuff on here, because that would do deep packet inspection in there. So it would be an inspection of the packet to see what if there was anything bad. If there was something bad in there, then you'd get denied or forbidden or some kind of message like that. Or in some cases, if it's an API, it just drops the packets, it doesn't return any status at all. So, yeah, that's the other thing you could do. So you use a app service environment which is of type internal, not external, and then at the VNet you attach the tail end of your WAF, and at the public IP address you attach the front end of your WAF. Okay, I hope you got something from that. I hope it made sense. I hope that you can use this in some way. Cheers then. I think I'll go now. Bye.